Welcome to Strange History. This season, we are talking about science, space, archaeology, and, well, really anything science. The oldest known artifacts are objects that provide evidence of human activity and date back thousands of years. Here are some examples. The Oldowan tools. The oldest known tools made by early humans are from the Oldowan culture, dating back approximately 2.6 million years ago. These tools were simple stone flakes with sharp edges and were used for cutting and scraping. The next one is I'm going to pronounce this, the Lomek stone tools, discovered in Kenya. These stone tools are estimated to be around 3.3 million years old. These tools are more complex than the Oldowan tools and indicate a greater level of technological advancement. The Schoeningen spears. These wooden spears were found in Germany and are approximately 400,000 years old. They provide evidence of early human hunting techniques. Of course, we have cave paintings. Some of the oldest known cave paintings were found in the Schoeningen cave in France and are estimated to be around 30 to 40,000 years old. These paintings depict various animals and are a testament to early humans' artistic abilities. The Venus figurines. Venus figurines are small statuettes depicting the female form. The oldest known example is the Venus of Hohlfels, discovered in Germany, which is estimated to be around 40,000 years old. These figurines provide insight into early human symbolism and culture. Of course, we can't forget about Stonehenge. Stonehenge is a prehistoric monument in England constructed between 3000 and 2000 BC. The exact purpose of Stonehenge is still debated, but it is believed to have been a ceremonial site or a burial ground. These are just a few examples of the oldest known artifacts, but archaeological discoveries continue to shed light on early human history, pushing back the boundaries of our knowledge. The Oldowan tools, which are the oldest known stone tool technology, which we mentioned before, are named after the Oldowan Gorge in Tanzania, where they were first discovered. The origins and the developments of the origin industry dates back to approximately 2.6 million years ago, and it's associated with early Homo sapiens, such as Homo habilis and possibly Australopithecus gari. These tools were simple in design and primarily made by striking flakes off a core of a stone. The tool characteristics of the Oldowan tools are typically small, handheld, and made from various types of rocks, including chert, quartzite, and basalt. They consist of sharp-edged flakes and cores. They were used for cutting, scraping, butchering, and whatever else they needed to use knives for that we would today. The tools were primarily used for basic survival needs and shaping raw materials. The production of the Oldowan tools involved a simple knapping technique known as percussion flaking. A stone core was struck with another stone, resulting in a detachment of sharp-edged flakes. These flakes were then used as tools, and the process could be repeated on the same core to produce additional flakes. The development and use of Oldowan tools indicate early hominins' ability to intentionally modify their environment and adapt to different ecological niches. They represent a significant milestone in human evolutionary history, showing early tool use and cognitive abilities of our ancestors. Oldowan tools have been found across Africa, including sites in Ethiopia, Kenya, Tanzania, and South Africa. They also appear in other regions, such as the Georgian Republic and Pakistan, suggesting a broader geographic distribution. The production and use of Oldowan tools likely involved social learning and transmission of knowledge within early hominin groups. Toolmaking and tool use might have been a facilitated cooperation, sharing of resources, and division of labor among individuals. Over time, the Oldowan tool industry gradually evolved into more sophisticated stone tool technologies, such as the Acheulean industry, characterized by the production of hand axes and bifacial tools. Further research into the Oldowan tools can provide more specific information about particular sites, the type of activities they were used for, and their significance in understanding early human behavior and cognition. To make such small tools, it means brain-to-hand coordination was advanced, and these were not simply monkeys hanging on rocks. They were a species of humans that used tools to survive. Next, we're going to talk about the Lomek stone tools. They were a set of prehistoric stone tools that were discovered on a site near Lake Turkana in Kenya. These tools were discovered in 2011 by a team of archaeologists led by Sonia Harmon and Jason Lewis. The tools were found in sediments dating back to approximately 3.3 million years ago, making them the oldest known stone tools, predating the previously recognized Oldowan tools. These stone tools are distinct in their appearance and technological characteristics. They are larger and more robust compared to the later Oldowan tools. The tools consist of cores and sharp-edged flakes that were produced by a process called bipolar knapping. Unlike the Oldowan tools, these tools were made by hammering large stones into a core and then detaching flakes, rather than striking the core directly. The discovery of these stone tools challenges the conventional understanding of the origins of stone tool technology. It suggests that early hominins, potentially a species of Australopithecus, had the cognitive ability to intentionally shape and modify rocks for specific purposes. These tools represent a significant milestone in human evolutionary history, and they highlight a technological diversity during this early period. This site was located in a wooded environment near a river, suggesting that early hominins who made these tools inhabited a diverse, resource-rich landscape. These tools were likely used for various activities, such as cutting, scraping, processing plant materials, butchering animal carcasses, etc. These stone tools indicate that stone tool-making technology emerged earlier in the human evolutionary timeline than previously thought. This suggests that early hominins had the capacity for complex manual dexterity, problem-solving skills, and cultural transmission of knowledge. They differ from the later Oldowan tools in their size, shape, and manufacturing techniques. These tools were more primitive in nature, utilizing a different knapping method. This indicates that different stone tool technologies coexisted and evolved over time during the early stages of human evolution. The discovery of the stone tools have sparked further research and excavation of the region. Archaeologists continue to explore the site and nearby areas to uncover additional artifacts and gain a deeper understanding of early hominin behavior and tool-making capabilities. Studying these tools provides valuable insight into the cognitive abilities, technological advancements, and behavior patterns of our very early ancestors. Next, we're going to talk about the Schoeningen spears, also known as the Schoeningen lances. They are a collection of ancient wooden spears discovered in the Schoeningen open-cast lignite mine in Germany. These spears were discovered during excavation of the Schoeningen mine in the 1990s. The first spear was found in 1994, and subsequent excavations led to the discovery of several more spears, as well as other artifacts. The spears are estimated to be around 300 to 400,000 years old, dating back to the Middle Pleistocene, which makes these spears remarkable in their remarkable state of preservation due to being buried in waterlogged soil, which prevented the wood from decaying. These spears were carefully crafted from the wood of spruce trees. They measure between 1.8 and 2.2 meters, approximately 6 to 7 feet in length, and have a sharpened point at one end. The spears were likely used as hunting weapons. The discovery of the Schoeningen spears provide direct evidence of early human techniques for hunting. The well-preserved wooden spears suggest that early humans had the ability to plan and execute organized hunts using spears for thrusting and potentially as throwing weapons. The Schoeningen spears have important implications for our understanding of human evolution. The ability to manufacture and effectively use spears indicates advanced cognitive and physical abilities, including planning, coordinating, and cooperating. It suggests that early humans had developed sophisticated hunting strategies and tools to secure food resources. The spears were found in association with other artifacts, such as stone tools, and the remains of large mammals, including horses and elephants. Side note, did you know there were elephants in Germany at one point? Elephants ranged over the Schoeningen in Lower Saxony 300,000 years ago. In recent years, remains of at least 10 elephants have been found in these Paleolithic sites situated on the edges of the former open-cast lignite mine. Researchers conducted experiments with replicas of Schoeningen spears to understand their performance and functionality. These experiments showed that the spears were effective for hunting large game, demonstrating their practical use for ancient hunting activities. So I guess some modern men got together and threw some sticks around and discovered they worked. The London hammer. This is my most exciting favorite one. The London hammer, also known as the London artifact, is a controversial object that has been cited by some as evidence of an anomalous or out-of-place artifact. Here is some information regarding the London hammer. It was discovered in June of 1936 near London, Texas, in the United States. According to the story, it was found embedded in a rock formation known as the Cretaceous limestone, which dates back to around 110 to 130 million years ago. The London hammer is described as a metal hammerhead attached to a wooden handle. It is said to be approximately 6.5 inches long and made of iron. The wooden handle appears to be partially mineralized. The London hammer has sparked debate and controversy among archaeologists, geologists, and other experts. Some individuals have claimed that the artifact's evidence of an ancient advanced civilization or time travel. I don't think so. However, the scientific consensus is that the London hammer is not an out-of-place artifact, but rather a modern object that was mistakenly encased in a rock formation due to a natural geological process. Geologists have proposed several explanations for the London hammer's presence in this rock formation. One possibility is that it's an example of a concretion which occurs when minerals precipitate and harden around a pre-existing object, creating the appearance of an embedded artifact. Another explanation is that the hammer could have been left behind by a previous visitor or worker and subsequently encased in rock over time. The dating challenges, though. The age of the London hammer is contentious. While the rock formation it was found in is believed to be around 110 to 130 million years old, the hammer itself has not been definitively dated. In the absence of precise dating, the artifact's age cannot be reliably determined. There's been a lack of scientific study. The London hammer has not undergone extensive scientific analysis or peer-reviewed research. Its state as an anomalous artifact has not been substantiated by rigorous scientific investigation or documentation, meaning they haven't looked into it yet properly. Let's move on to astrolabes. An astrolabe is a historic astronomical instrument used to measure the altitude of celestial bodies and determine their positions in the sky. The astrolabe originated in ancient Greece around the 2nd century BC, was further developed by astronomers and mathematicians in the Islamic world during the Middle Ages. It later spread to Europe and other regions. An astrolabe typically consists of a disc or plate with engraved markings and a pivoting alidade or ruler-like component. The disc represents the celestial sphere, while the alidade serves as a sighting mechanism. It includes various scales such as horizon, zodiac, and altitude scales used for celestial measurements. Astrolabes were primarily used for astronomical and navigational purposes. They allowed users to determine the altitude of celestial bodies, such as the sun, stars, and planets, and calculate time, azimuths, and declinations. Astrolabes were also utilized for surveying, astrology, and determining prayer times in Islamic cultures. Over time, astrolabes underwent numerous variations and refinements. Different designs and features emerged, including planispheric astrolabes, spherical astrolabes, and universal astrolabes. Each variant had its own set of scales and capabilities tailored for specific astronomical calculations. Astrolabes were essential tools for astronomers, navigators, and scholars in ancient and medieval times. They helped advance understanding of celestial movements, improved navigation and map-making techniques, and contributed to astronomical observations and calculations. Astrolabes also played a role in the transmission of scientific knowledge between culture and civilizations. With the advent of more advanced instruments such as the sextant and the telescope, the use of astrolabes gradually declined by the 17th century. Astrolabes were mostly replaced by more precise and specialized instruments. However, they still hold historical and educational value, and some individuals collect and study astrolabes as artifacts and tools of scientific heritage. The next one is hard for me to pronounce, so bear with me, people. The Antikythera mechanism. It's an ancient Greek mechanical device that is considered one of the most significant archaeological discoveries in the field of ancient technology. This mechanism was discovered in 1901 by Greek sponge divers off the coast of the Greek islands of Antikythera. It was found among the wreckage of a Roman cargo ship that sank around 60 BC. You've probably seen it on TV and some article on the news where it's that metal object they found that looks like a mechanical device that kind of baffled scientists over the years. Anyway, this mechanism is an intricate bronze device composed of a series of gears and dials. It is estimated to have been originally housed in a wooden case and had a front and back panel with inscriptions and markings. The mechanism is about the size of a shoebox. Through careful analysis and reconstruction, researchers have determined that this mechanism was a sophisticated astronomical calculator. It was designed to predict and display celestial events, including the positions of the sun, moon, planet, and eclipses. It also likely served as a calendar and possibly had additional features related to ancient Greek astrology. The mechanism utilized a complex system of gears and wheels to model the movement of celestial bodies based on ancient Greek astronomical theories. It could be adjusted and manipulated to account for the irregularities in the motions of the planets and predict their positions with impressive accuracy. This mechanism is a testament to the advanced knowledge and technical skills possessed by ancient Greek engineers and astronomers. Its level of complexity was previously thought to be beyond what was achievable during the time period. It demonstrates the Greeks' understanding of celestial mechanics and their desire to create mechanical models to study and explain the cosmos. The deciphering of the inscriptions and the internal structure of the mechanism has been a challenging task. Scholars and scientists have employed various techniques, including X-ray imaging, CT scanning, and computer modeling. It's to reveal the mechanism's inner workings and recreate its original appearance. The mechanism provides valuable insights into the technological achievements and scientific knowledge of ancient Greece. It serves as a reminder of the level of sophistication reached by an ancient civilization and the potential existence for other lost technological wonders. This mechanism remains an object of fascination and study, shedding light on the intersecting of ancient astronomy, mechanics, and craftsmanship. It stands as a remarkable artifact that challenges our understanding of the technological capabilities of the ancient world. Let's move on to the Viking sunstone. Next week, by the way, we're going to be talking about Viking artifacts, but I wanted to put this one in here because it kind of fits. So the Viking sunstone, also known as a sun compass or solarstein in Old Norse, is a historical navigational tool associated with seafaring Vikings. Historical context. The Viking sunstone was used during the Viking Age, which spanned from the late 8th century to the 11th century AD. The Vikings were skilled seafarers who navigated the vast expanses of the North Atlantic, including the often overcast and foggy regions of the Scandinavian waters. The function and the purpose of the Viking sunstone was believed to aid navigation by determining the position of the sun, even when it was obscured by the clouds, fog, or during twilight hours. It allowed Viking sailors to estimate the sun's position in the sky, which helped them establish their heading and navigate their ships. Basically, they would hold this crystal up towards the sky and look through it, and they would actually be able to see the sun no matter how overcast it was. They could see where it was coming from. So it helped them navigate better. The sunstone is theorized to be a crystal or a mineral with certain optical properties that enabled Viking navigators to detect the polarization of light. By holding the sunstone up to the sky and rotating it, the Vikings could identify the position of the sun and use it as a reference for navigation. Speculation and historical reference. Let's see. The exact nature of the sunstone is not definitively known, since no archaeological examples have been found. References to the sunstone, however, can be found in ancient Norse sagas and legends, including the saga of King Olaf and the saga of Saint Olaf. These references describe the use of the sunstone or a sun's path for navigation. In recent years, there have been scientific interest in identifying the potential mineral or crystals that could have served as the Viking sunstone. Calcite and Iceland spar, a transparent form of calcite, have been suggested as possible candidates due to their birefringent properties that can detect polarized light. Controversy and interpretation. Let's see. The existence and the effectiveness of the Viking sunstone as a practical navigational tool have been subject to debate. Some scholars argue that Viking navigators possessed sufficient celestial knowledge and navigational skills to determine the sun's position without relying on a specialized tool like the sunstone. Others believe that the sunstone could have been a helpful aid in certain conditions. I, for one, think we shouldn't be so close-minded, and they probably did have something like this. Anyway, this has been another episode of the Strange History Podcast. I hope you enjoyed it. I love history, and this was a fun one to make. Thanks, Spreaker, for being the easiest podcast platform to use, and it's free. Check it out. You can even make money using it. Thank you, Darkcast Network, and thank you to one of my favorite humans on the earth, Dead to Me Productions, for making me sound like I know what I'm doing every single week. Peace out. Yay!